All right, welcome to Geometry. Let's go ahead and get started. We are on 4.7, so please go to page 204 of your textbook. Page 204 of your textbook. While you're turning there, you guys have a quiz tomorrow over 4.4 to 4.7. This will be quiz number 33. Quiz 33 over 4.4 to 4.7. If it feels like we skipped a few quizzes, it's because we did.
Yay. You never announced it.
Oh, my word. Huh? Yes. Yes, I will announce that at the end. All right, so that's what we're doing. We're doing 4.7 today. We have a quiz from 4.4 to 4.7 tomorrow, which will be quiz number 33. And let's get into 4.7. You should be on page 204 of your textbook right now, which means your textbook should probably be open and in front of you. And we'll get started here. First thing we need to cover is Theorem 57. If two triangles have the three angles of one equal to the three angles of the other, then the triangles are similar. So we're given here two triangles. If you can't see the diagram real well, then you can go ahead and, first of all, I'm going to move myself out of the way because I think I was on the bottom right for all these. I don't know. I'm trying to remember my camera layout from last year. Anyway, but Theorem 57, if you can't see the diagrams on here, it's the same diagram as on page 204. Literally, all I did was scan and invert it. So it's the same figures. But let's go ahead and get going into the proof here. First statement, for the record, the diagram is not covering any text, so you guys don't have to worry about that. But we have our given, which we have triangles ABC and A prime, B prime, C prime, with angle A is equal to angle A prime, angle B is equal to angle B prime, and angle C is equal to angle C prime. Not this one, no. No, we've proven them congruent, not similar. We're placing triangle A prime, B prime, C prime on a triangle ABC so that A prime falls on A and A prime, B prime falls along AB, because a geometric figure may be freely moved in space without any change in form or size. A prime, C prime then falls along AC by definition of equal angles, and B prime, C prime must be parallel to BC, because when two straight lines are cut by a transversal, if two corresponding angles are equal, then the two lines are parallel. Number 5, then AB must be proportional to A prime B prime and AC must be proportional to A prime C prime, because the line parallel to one side of a triangle divides the other two sides proportional to either of their corresponding segments. By the way, this proof is also in your text on pages 204 and 205. This is the same proof, so you guys have it there. You guys don't have to worry about trying to get it down anywhere. All right, so as we move on, the diagram again has just been shifted to allow it to not block anything. We're placing triangle A prime, B prime, C prime on triangle ABC so that B prime falls on B and B prime A prime falls along BA, because we can move anything around however much we want. So because we have only angles, we have no sides to work with, we're having to move this triangle around twice. Okay? And so B prime, C prime falls along BC. So then A prime, C prime is parallel to AC. This is very similar to the previous section of the proof. So then we have those sides proportional. Well, two things proportional to the same thing are proportional to each other, so we have step 10. And then finally, that means we have similar polygons because we have proportional sides and equal angles. Yes?
So that little line was just squiggly means similar?
Yes.
So that's why it's an equal plus.
Yes. Because it's equal area, because remember the equal sign in geometry only refers to the number of its area. So if it's 42 square units, whether it's triangle or square, if they're both 42 square units, they're equal. So you can actually have a triangle equal to a square, as weird as that sounds. So that's why the congruent symbol is weird. Okay, that doesn't go away. All right, Theorem 57. Moving on here, we do have a couple corollaries that use the same diagrams. If two angles of one triangle are equal respectively to two angles of the other, then the triangles are similar. We actually just proved this in the previous statement. We only actually dealt with 2 out of the 3 angles, and we were able to prove it. So we actually don't need the third angle. That's represented by lowercase aa. We're going to assume corollaries proven in this section, mostly because I didn't feel like retyping the proofs when I wrote these. All right, corollary 57.2. Two right triangles are similar if an acute angle of one is equal to an acute angle of the other, because, again, if you have right triangles, that means one of them is a right angle. So those have to be equal because all right angles are equal. All right, moving on. Theorem 58. If two triangles have two pairs of sides proportional and the included angles equal respectively, then the triangles are similar. Again, notice lowercase SAS, because it's not congruent. Congruency uses uppercase, lowercase is similarity. All right, so let's go ahead and discuss the proof on this one. Triangle ABC and triangle A prime B prime C prime with angle A equal to angle A prime and the two sides proportional. This proof is not in your textbook, but I'm not super worried about it. All right, so we are going to draw AD equal to A prime B prime on AB. And we'll draw AE. Basically, we're cutting off the equal segments on AC. Okay, so just using our compass and cutting off equal segments. Then we'll draw DE where because 2 points determine a line. So triangle ADC, or sorry, excuse me, ADE is congruent to triangle A prime B prime C prime. Basically, we moved the triangle up, excuse me, onto the other triangle, but we did it through constructions instead of just being like, hey, I used scissors, cut out a triangle and moved it. So we just constructed equal sides. Anyway, moving on. So with this, then angle ADE must be equal to angle B prime because CPCTE. So AB is to AD as AC is to AE by substitution, which makes DE parallel to BC because the line that divides two sides of a triangle proportionally is parallel to the third side. And so then the corresponding angles of parallel lines are equal, so angle ADE must be equal to angle B. Well, since angle B is equal to angle B prime, or sorry, since angle B equals angle ADE and angle B prime equals angle ADE, then angle B must equal angle B prime, and then just through angle, because we were given one of the angles, we have similar triangles. Along these lines, we get corollary 58:1. If the legs of one right triangle are proportional to the legs of another, the triangles are similar. We call this leg-leg. Okay, again, lowercase for similarity. All right, Theorem 59. If two triangles have their sides respectively proportional, then the triangles are similar. All right, so this is side, side, side. Again, lowercase because similarity. Let's discuss the proof, and let's make sure we're not discussing other things while I'm discussing this. Gabby. All right, so we have our given two triangles along with proportional sides. We're going to mark AD on AB so that AD is equal to A prime B prime, and mark AE on AC so that AE equals A prime C prime. Then we'll draw DE, and then our goal is going to be to prove DE is equal to B prime C prime. All right, so we have proportional sides by substitution by corollary 54:1, which is, what is corollary 54:1? This is why you don't do this. This right here, because I don't remember what corollary 54:1 is. That's my point. We mentioned this is actually specifically with triangles. If we have proportional sides, then we have parallel lines. All right. Finally, angle ADE must equal angle B. Angle AED must equal angle C because two parallel lines cut by transversal form. Whoops, sorry, that should say form, not from. Equal corresponding angles. All right, so moving on here, then we have two we have two similar triangles by AA. Which then means corresponding sides of similar triangles are proportional. So I can say AB is to AD as BC is to DE. So we've proven those two sides to be, or we've proven these two triangles to be similar. Now we're trying to prove these two triangles to be congruent. Basically to prove B prime C prime equal to DE. No, we're going the other way. Sorry, we're proving DE equal to B prime C prime first. All right, so through substitution of steps 2 and 8, we're allowed to say step 9, which basically allows us to plug in A prime B prime to AD. Then DE must equal B prime C prime by property 1 corollary 1 of proportions on page 192. This means that ADE is congruent to A prime B prime C prime. And so since those two are congruent, angle ADE is equal to angle B prime, angle AED is equal to angle C prime by CPCTE. Then by substitution, angle B prime must equal angle B, angle C prime must equal angle C, and we have similar triangles by AA. Make sense? Clear as mud?
Yeah.
Cool. All right. Homework tonight, 1 and 3. You do have, they are proofs.
Come on, 1 and 3. That looks like it says number 1 and 3.
That's what I said.
1, 2, 3.
No, 1 and 3.
1 column.
Yeah, 1 and 3. 1 and 3 is your homework. Douglas, stop arguing with me. 1 and 3 is your homework. Okay, you can do 2 if you really want to, but it's not assigned. No.
But come.
What? It says prove, so yes.
Why are we jumping back and forth? This doesn't work.
Because geometry. All right, distance learners, we'll see you guys later.